Hey everyone! Today, we're diving into one of geometry's most basic shapes, but we're gonna look at it in a new way. We're talking about the area of a triangle. And here's the cool part. The secret to figuring it out has been hiding in plain sight this whole time, inside a shape you already know.
So how do you measure what's inside a pointy shape? I mean, think about it. Triangles can seem a little tricky, right? All those sharp angles, those slanted lines. How do you get a solid measurement for the space inside? It feels like it should be complicated, but you'll see the solution is actually super simple. We just have to start by looking somewhere else. And that somewhere else is a shape we all know and love, a simple rectangle. We've known for ages how to find its area, right? It's just base times height. Easy. And believe it or not, that one simple fact is the only key we need to unlock the triangle puzzle. Okay, now for the fun part, a little bit of geometric magic. Imagine taking any old rectangle. Now slice it right down the middle, corner to corner. What do you get? Boom, two perfectly equal triangles. And this isn't some kind of trick. It's a fundamental truth about how these shapes are related. And there it is. That's the secret, the big reveal. If a rectangle's area is base times height, and we just saw with our own eyes that a triangle is exactly half of that rectangle, well then its area has to be half of the base times the height. It really is that straightforward. So now that we get the why behind it, we can put a nice clean definition on it. The area of a triangle, it's just the space inside its three sides. And the best part is, we now have this simple but incredibly powerful formula to calculate it every single time. All right, let's look at the formula itself. Area equals 1/2 times base times height. The base part is super easy. You can just pick any of the triangle's three sides to be your base. But the height, now this is the really important part. The height is not the length of the slanted side. Nope. It's the straight line distance, a perfect 90-degree angle, from the base all the way up to the opposite corner. Okay, that's enough theory. The best way to really get a feel for a tool like this is to actually use it, right? So let's put it to work. We'll run through a couple of quick examples just to see how clean and consistent it is. Okay, first up, let's say we have a triangle with a base of 5 centimeters and a height of 4 centimeters. So we do base times height, 5 times 4 is 20, and then we just take half of that. So our area is 10 square centimeters. Simple. Let's do another one. How about a base of 7 and a height of 3? Okay, 7 times 3 is 21. Cut that in half, and you get 10.5 square centimeters. See how it works? All right, one last one to lock it in. Base is 8, height is 6. So 8 times 6 is 48. Half of 48 is 24 square centimeters. It works every single time. The logic is just perfect. Pretty cool, right? But, this is way more than just a neat math trick or numbers on a screen. This simple little formula, it's actually a fundamental building block of the world we live in. I mean it. This isn't some abstract thing you only see in a textbook. Architects, engineers, they use this exact calculation literally every single day. It's a core tool for designing and building pretty much everything you see. Seriously, just look around. You see a roof over a house? The strong, stable frame holding it up is made of triangles. Why? Because they distribute weight perfectly. Or think about a massive bridge, that intricate web of steel that holds the whole thing up. It's called a truss, and it's built from, you guessed it, triangles. They are just incredibly good at handling forces like tension and compression. It's basically nature's strongest, most efficient shape. So when you really think about it, what we've uncovered here isn't just a formula. It's like learning a word in a much bigger language. It's the language of design, the one we use to understand how the world is built and how to build our own amazing things inside of it. And that kind of leaves me with one last question. If a shape this simple, with a secret that's just about cutting a rectangle in half, is one of the foundations of all modern engineering, it makes you wonder, right? What other huge, world-changing ideas are hiding right there in plain sight, just waiting for us to notice them?